10.2. In this section, we're going to solve absolute value equations. That is, equations that have absolute values in them with variables as well. So let's start with a very simple example. Let's solve the equation, the absolute value of x is equal to 7. There are two possible values of x that could make this true. Okay, because what you want to remember is that absolute value means distance from 0. Okay, and there are two numbers whose distance from 0 is 7. Okay, one of them is, of course, 7. It's 7 units away from 0, but you can also go away from 0 in the negative direction. Okay, -7 is also 7 units away from 0. Therefore, x could be either positive or -7. Those are two separate numbers. When you write it like this with a plus or minus, that's the same as saying x equals 7 or -7 like that. Okay, and that's true because, let's check, if you plug that in, you get the absolute value of 7 equals 7. Well, that's true because the absolute value of 7 is 7. And if you plug in the other one, you get the absolute value of -7 is 7, which is also true. Okay, so when you have an absolute value of something equals a number, essentially what you can think of is think of this as being some other quantity. Let's just call it y for now. Okay, that means then that the absolute value of y equals 5, which means that y either equals positive 5. Let me just write that with the, oops. Let me just write that without the positive. So either y equals positive 5 or y equals -5. And then if I replace y by what I'm calling y, which is 2x minus 3, we have 2x minus 3 equals 5, or 2x minus 3 equals -5. Okay, so when you're solving absolute value equations, what you typically do is you say what's in the absolute value is either equal to the positive of what's on the other side or equal to the negative of what's on the other side. And you'll just jump straight here to this step without involving a third variable such as y. And then we can solve each of these two equations to find the two x's that make this true. Adding 3 to both sides of this equation gives us 2x equals 8, and so x equals 4. Or on this side, we'd have 2x equals, let's see, -5 plus 3 is -2, so x is -1. Those are our two answers. Let's also check on this one just to make sure that you're following. If x equals 4, let's plug that in and see if it works. Does the absolute value of 2 times 4 minus 3 equal to 5? Well, 2 times 4 is 8, minus 3 is 5, so the absolute value of 5 does equal 5. That one is true. And if we try -1, the absolute value of 2 times -1 minus 3, does that equal 5? 2 times -1 is -2. -2 minus 3 is -5, but that's still true. The absolute value of -5 is also 5. So those are the two solutions to this equation. So when you solve an absolute value of something is equal to a number or is equal to something, you put a positive, you set what's in the absolute value equal to the positive of what's on the other side and equal to the negative of what's on the other side. So I'm going to jump straight to that step on this next example and say, well, we have an absolute value of something is equal to 15. So either x over 5 plus 1 is equal to the positive of 15, or x over 5 plus 1 is equal to the negative of 15. Okay, and that's how you eliminate the absolute values. You have to get rid of the absolute value bars in order to solve for x. You can't just add 3 to both sides and keep the absolute value bars here. That doesn't work. You won't get the right answer. So then we solve these two equations. Okay, to get x over 5 equals 14. So x is equal to 14 times 5, which is, check it on your calculator, 70. And over here, we have x over 5 is equal to -15 minus 1 is -16. So if 14 times 5 is 17, then 16 times 5 would be 70. 16 times 5 would be 80. So x would be -80 as the other solution. Let's do yet another example. Now this one is slightly different from the ones we just did because the absolute value is not solved for. You also have this 8 on the one side. So when solving equations like this, you have to first isolate the absolute value, which means to get it by itself on one side of the equation. And this is how I abbreviate absolute value. I just put ABS. That's a common abbreviation. So first we have to get absolute value of 3x by itself. Well, we can do that by simply just subtracting 8 from both sides because that's not in the absolute value, so standard rules apply. 14 minus 8 is 6. And now we have an absolute value equation with the absolute value on one side equal to something else. So we set what's in the absolute value equal to the positive of what's on the other side and equal to the negative of what's on the other side. Solving each of these for x gives us 2 and negative 2. Okay, on this one, solve the absolute value of z equals 0. Okay, you could set it up the same way and say that then z is positive 0 or z is negative 0, but positive 0 and negative 0 are the same thing. Okay, so z just equals 0 because the distance from 0 to 0 is 0. So that's the only solution there. All right, solving this one, make sure you're trying these on your own first, pausing the video. Solving this one, first we need to isolate the absolute value. So we have 3 times the absolute value of z equals, subtracting 9 from both sides, we have 7 minus 9 is negative 2. Now we can divide both sides by 3 to get the absolute value of z equals negative 2/3. Now this is odd because we got that the absolute value of something is equal to a negative number. Now remember, absolute value is distance from 0. No distance will ever be negative. Okay, the other way to think of absolute value is that you make what's in the absolute value positive. So the absolute value of negative 7, you just make it positive, so it's positive 7. So no absolute value will ever equal a negative number. So this has no solution. And for the same reason, this next example doesn't make any sense either because it's also equal to a negative number. Okay, you don't even have to do any work. You can just say the absolute value will never equal a negative number. Therefore, this thing clearly has no solutions. Okay, let's look at when you have two absolute values in the equation and they are equal to each other. Okay, it's not all that different. First, I want to explain why I'm going to do it the way I am using just a very simple example. Okay, let's look at all the different ways two absolute values can be equal. Let's just use a simple number. Let's go with 3. All right, the absolute value of 3 is equal to two things. It's equal to the absolute value of 3, or you can say the absolute value of 3 is equal to the absolute value of negative 3. Or you could say another way two absolute values could be true is if they were both negative on the inside. The absolute value of negative 3 equals negative 3. Or the only other way you could put it is to reverse this equation, and it's true if the absolute value of negative 3 equals the absolute value of 3. So these are the only possible 4 ways that you can have two absolute values equal to each other. And really, two of them are the same. Either these two are equivalent because either the insides are the same. So notice what's on the inside of both absolute values on both sides of the equation are equivalent, or the insides are opposite of each other. Like here, one side is positive, one side is negative. One side's positive, one side's negative. So either they're the same or they are opposites. So in solving this example, we can say either the two insides are equal or they are opposites of each other. Therefore, we'll have either 2x plus 4 is equal to 3x minus 1. Their insides are equal, or their insides are opposite, so 2x plus 4 could equal the negative of 3x minus 1. If we set the two insides equal, well, then we just solve each of these equations. So on this first equation, I'm going to subtract 2x from both sides and add 1 to both sides. So we get x equals 5. And on this equation, first we have to distribute that negative. Then I'll add 3x to both sides and subtract 4 from both sides to get x equals negative 3/5. Now if you're doing one like this and you're not entirely sure, why don't you check your answer? If we check x equals 5, we get the absolute value of 2 times 5 plus 4. Does that equal the absolute value of 3 times 5 minus 1? Okay, 2 times 5 is 10, plus 4 is 14. Absolute value of 14 is 14. 3 times 5 is 15, minus 1 is 14, whose absolute value is also 14, so that one works. And this negative 3/5, let's see about it. Does the absolute value of 2 times negative 3/5 plus 4 equal the absolute value of 3 times negative 3/5 minus 1? Okay, then on this left side we have negative 6/5 plus 4. In order to add those, I'm going to need a common denominator, so I'll rewrite 4 as 20/5. Does that equal negative 9/5, the absolute value of negative 9/5 minus 5/5? 20 minus 6 is 14, so does the absolute value of 14/5 equal? Over here we have negative 14/5 inside the absolute value, and yes, those are equal. So these are your two solutions. And let's do one more like this. Setting these equal, we get either, their insides are equal, so either x minus 2 equals 8 minus x, or x minus 2 equals the negative of 8 minus x. Solving here, adding x to both sides, we get 2x, and adding 2 to both sides equals 10. So x is 5. And over here, after we distribute that negative, oh, this is interesting. After we distribute that negative, I get x minus 2 equals the negative of x minus 8, so negative 8 plus x. If you subtract x from both sides, you get negative 2 equals negative 8. Well, that's not possible, so this particular side actually has no solution. So x equals 5 should be the only solution. And let's just check that using mental math real quick. If we plug in 5 up here, we're going to get absolute value of 3, which is 3. If we plug in 5 over here, we also get absolute value of 3, which is 3. So that works. It just happens that this one only has one solution. So that's it for absolute value equations. Tune in next time for absolute value inequalities.